This is the Math 2 lesson summary video for the lesson entitled Factor Fixin, the X Factor. The purpose of Lesson 6 of Unit 4, Factor Fixin, the X Factor, is to use rectangular area models in order to learn how to factor quadratic functions in the form x squared plus bx plus c. In prior modules of this unit, we have used square area models, and in this unit, or in this lesson, we will be using rectangular area models. At first, Optima's quilts only made square blocks for quilters. But then Optima found that many customers that came into the store were making designs that required a combination of squares and rectangles. So we are then told that some customers started coming into the store, and for example, one line of quilt blocks consisted of starting with a square block and extending it by 5 inches and the other side length by 2 inches to form a new rectangular block. We know that this would be a rectangle because the two side lengths are not the same number. So now we are asked in number 1 if we can find a different expression to represent the area of this new rectangular block. Let's first use our algebra tiles like we did in class in order to demonstrate visually what this area model would look like. So what I've done here is I've used the algebra tiles to create a visual representation of this rectangular block. And then we were asked to find a different expression that would represent the area. So we're trying to represent this here down below. So what we've done here is we know this is an x by x or an x squared area in blue. Each of the rectangles are +1. So essentially, as a reminder, that means we have an x plus 5 on this side, and we have an x plus 1 plus 1, so we have an x plus 2 on this side. Therefore, this indeed is the area, because when we multiply length times width in a rectangle, we would get x plus 5 times the quantity x plus 2. And we're asked to write this in a different equivalent form. So what we could do here is we could distribute our two parentheses. X times x is x squared, x times 2, 2x, plus 5x, and 5 times 2 is 10. And if we combine our like terms, an equivalent expression for this area would be x squared plus 7x plus 10. So we were asked to convince the customers using a diagram and a formula, and we have just done so here. So in number 2, we are given some additional new lines of blocks that Optima's Quilts has produced, and we're asked to find 2 different algebraic expressions to represent each rectangle and illustrate with a diagram why your representations are correct. So let's first read number 2, the original square block. So the original square block means that we're working with Optima's original x by x squared. And it was extended by 3 inches on one side. So we should have plus 3, 1, 2, 3. That's plus 3. And 4 on the other. So we should have 1, 2, 3, and 4. So this is x plus 4. Therefore, the area of this, and I didn't write the bottom right corner, but we did use algebra tiles in class, would be x plus 3 times the quantity x plus 4. That would be one algebraic expression. A second would be if we distribute the parentheses and we multiply, we'll get x squared plus 4x plus 3x is 7x, and 3 times 4 is 12. So both of these here are equivalent algebraic expressions for the order that was received. And then in 3, we're told the original square block was extended 4 inches only on one side. So without drawing a diagram on that, let's think about what that would look like. We know if it's only on one side, then one side needs to be x plus 4, but the other side still remains x. So therefore, we can distribute that. An equivalent expression would be x squared plus 4x. In number 4, we were told that a new customer wants a block with one side that is the standard length x and one side that is 2 inches less than the standard side. So what we discussed in class is when we're subtracting 2, instead of using the purple or the green color, we would use red. So in the diagram that's here, this is still an x by x square, but each of these would represent -1. Therefore, the area of this rectangle would have one side with an x minus 2 length and the other side with an x length. A second equivalent form would be if we distributed the x, we will get x squared minus 2x. Moving along to number 8, the customer service department in Optimus Quilts has placed the following orders on our desk, and we're asked to describe how to make the new blocks by extending the sides of a square block with an initial side length of x. So if we look at A, we're given the expression x squared plus 5x plus 3x plus 15. So we know that on one side, we should have, to get an x squared plus 5x, we should have 5 rectangles, because 5 times x will give us 5x. And then on the other side, we should have 3 rectangles. So an equivalent expression here could be x plus 5 times the quantity x plus 3. If we do distribute those two binomials, we will get x squared plus 5x plus 3x plus 15, which is what we started with. And if we combine our like terms on this, we see that we get x squared plus 8x plus 15. So these two are equivalent forms for the area of A. If we look at B, in this case we did use algebra tiles in class, but I'm going to write this out here without the algebra tiles. To get a x squared plus 4x, we would need an x plus 4 side length on the rectangle and an x plus 6. If we distribute those, let's double check that we're correct. We would get x squared plus 6x plus 4x plus 24. And that's indeed what the customer wanted. And when we combine like terms, we would get x squared plus 10x plus 24. So, as we progressed on 8, we started noticing a pattern. And we're going to keep going on 9 to see what pattern it is when we're asked to factor. So on 9, we're told that some of the orders are written in even more simplified algebraic code. And we're asked what these entries mean by finding the sides of the rectangles that have this area. In A, we are given the algebraic expression x squared plus 9x plus 8, and we need to figure out how to get that area. So essentially, we have to figure out how to get rectangles that add to 9, but multiply to 8. Now let's go back on number 8. If you notice, between my factors, I had 4 and 6, and those gave me my 10 rectangles if I added them together. And 4 times 6 gave me how many little green squares I had in the bottom right corner. 6 times 4 is 24. If we apply that on number 9, we know that two numbers that will get us 9, if we add 5 and 4, if we add 8 and 1. So let's try one of these. Which one of those will multiply to 8? And we know there's only one option. 8 times 1 is 8. So our equivalent form would be x plus 8 times the quantity x plus 1. Let's take a look at B. We need two numbers that will multiply to 3 because our rectangles have to add up to 3, and add to 3, and will multiply to negative 18. So let's think of what numbers multiply to negative 18. Well, we could have 6 times -3, or -3 times 6, or -18 times 1, or -1 times 18. We could also do 9 and -2, or -2 and 9. But I actually already see a combination here that would add to 3. If we take 6 minus 3, we will get 3. So an equivalent expression without me using the algebra tiles would be x plus 6 times the quantity x minus 3. Let's try another one. Let's look at one where both of the values, like in h, are negative. So now we need numbers that multiply to -4, because those will be our bottom green squares, and add to -3. So let's think first of our factors of -4, -1 times 4, -4 times 1. We could also do 2 times -2. If I look at these factors, I know that -4 plus 1 will give me 3. So -4 and +1 should be my factors. Therefore, an equivalent form would be x minus 4, x plus 1. We've noticed a pattern in 9. We've noticed that when we're trying to factor a quadratic function in the form x squared plus bx plus c, that if we find two numbers that multiply to c and add to b, we will be able to find an equivalent expression for the quadratic function. There was one more part of this investigation that looked slightly different. So let's move down to number 11. We had an unusual request at Optima's Quilt Shop. We were asked to find if there is a pattern or a way to predict two expressions for the area when one side is increased, in this case by 1, and the other side is decreased by 1. So when we see this, what would need to happen here is when we multiply these two out, we will get x squared minus 1x plus 1x minus 1. And we know that these two, when we add them together, would give us 0. Therefore, an equivalent expression for x plus 1 times the quantity x minus 1 is x squared minus 1. Likewise, let's look at b. Let's see if a pattern starts happening. If we multiply these two, we'll get x squared minus 3x plus 3x minus 9. And if we combine our like terms, we will simplify this to x squared minus 9. So notice there is no bx value. The pattern that we notice is when you have a positive number and a negative number, the bx will cancel out. So we are asked in 12, what pattern did we notice? What is the result of x plus a times the quantity x minus a? So the result will be x squared minus a squared always. This is often called, in mathematics, the difference of squares. Then looking at number 13, a customer has called and asked for a rectangle with an area of x squared plus 7x plus 9. If we use our pattern that we noticed in the previous problem, we should be able to find two numbers that multiply to 9 and add to 7. When we think of our factors of 9, we have 3 times 3, we have 9 times 1. If I look at those factors, do 3 plus 3 equal 7 or 9 plus 1? And the answer is no. So the customer service representative said that the shop couldn't make the rectangle. And we agree because of the fact that there are no two numbers that will multiply to 9 and add up to 7. So this quadratic expression is not factorable. To sum up today's lesson in how we factor a trinomial in the form x squared plus bx plus c, the first thing we need to do is write our factors. The second thing we need to do is decide on our signs. If the c value, which is on the end of the quadratic function, is positive, and the b value is also positive, then to factor we should get x plus a number, x plus a number. If c is positive but b is negative, then we should get x minus a number and x minus a number. If c is negative, then to factor we will get x plus a number and x minus a number. Now, the next question is, how do we figure out what goes in these blanks? Number 3, we have to decide on numbers that go in the blanks by thinking of factors about c. The two numbers must multiply to c and add to get b. So for example, if we are given the expression x squared plus 7x plus 10, we need to find two numbers that multiply to 10 and add to 7. 5 times 2 is 10, and 5 plus 2 is 7. Because my signs in this case are both positive, this would be an example of the first option. Therefore, my factors would be x plus 5 and x plus 2. We can check our answer by multiplying the two factors together to be sure that the expression is equivalent to the trinomial. So let's multiply our example. We get x squared plus 2x plus 5x plus 10. We combine our like terms and we get x squared plus 7x plus 10, which is exactly what we started with. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.